Hi, this is the second video in the playlist on the AQA New Specimen Papers, and it's the Paper 2 higher tier calculator version. Now if you want to download that paper, if you go to the link below in the description, you'll be able to download it. The whole idea is this is going to be a 20 to 30 minute video. Have a go at the questions, keep stopping the video, have a go at the questions, and then compare your solutions. Okay, we stopped in the previous one at question number 9, so we're going to move on with this one to question number 10. And question number 10 deals with well, basically ratio, and what it says is number of boys to the number of girls in school is 9 to 7. Okay, so again, like a lot of other things, what I tend to say is that, you know, find this first bit of information, don't read the rest of the question just yet, just do something with that. So what I'm going to do is I'm going to write boys to girls, and I'm going to write 9 to 7, which means that in this school there could be 16 children, okay, 9 of which would be boys and 7 of which would be girls. Now at the moment what they're saying is that if that was the case, the difference between the two would be 2. Okay, so there would be 2 more boys than girls. However, in the next line of the question, it actually tells us that's not the case. It's telling us there's actually 116 difference between boys and girls. There's 116 more boys. Okay, well if that is the case, then basically the grouping is 58 times bigger. Okay, so rather than having 2, it's 2 times 58, and that would mean then that the difference would be 116. So if we want to work out the number of boys and number of girls, all we do is we multiply by 58. Okay, and again, this is a calculator paper, so you could put this into your calculator and kind of work out for yourself, or you could do it by a formal written method, and what you would find is there would be 522 boys and 406 girls. Okay, and that's the information that you need in order to answer the question, which is the total number of students at the school is going to be 522 plus 406, and if I add those two together I get 928. So in this particular school there are 928 students. Okay, hope that's all right for you. Ratio does keep cropping up on these sorts of papers, so it is well worthwhile having a look at some other questions as well and familiarising yourself with how ratio works. Question number 11 is also fairly popular as well. Certainly within most papers you're going to get some form of quadratic equation in the higher papers, and it says circle the equation with the roots of 4 and minus 8. Okay, well what they mean by that is that if we look at this would be a kind of a sketch of how this quadratic would look, and it means that this would be 4 and this would be minus 8. Okay, now hopefully if you can see this and you've worked with quadratics, what we mean here is this is x plus 8 equals 0. So if x plus 8 equals 0, then x equals minus 8. Okay, and then similarly with x minus 4 equals 0, so x must equal 4. Okay, so the equation with the roots of 4 and minus 8 is going to be that particular equation. Okay, please do have a look at quadratics because they certainly will crop up quite frequently. Okay, so let's move on then to question number 12. And question number 12 asks you to work with standard form. Okay, all right, standard form is something that well, usually they crop up on both non-calculator and calculator questions, so it's well worthwhile again getting to grips with how to work with standard form. Okay, so what I'm going to do is I'm just going to write it out. So I've got a value of x and I've got a value of y. Now at the top of r here, or the top of this equation, I've got x squared. So just be a little bit careful about that. I can write r equals 3.6 times 10 to the power of 5, and that's squared, okay, and that's divided then by the value of y, which is 7.5 times 10 to the power of 4. Okay, now if you plug that into a calculator, actually the calculator, depending upon which model you've got, will give you an answer which is a whole number, so 1728000. So that's actually the answer to this question, but they want you to put it in standard form to an appropriate degree of accuracy. I don't really know what that means. I think there's a couple of things that you could do. Just for the sake of the examiner, you could write 1.728 times 10 to the power of 6, or if you wanted to do, you could write 1.7 times 10 to the power of 6, and then in here you could put to 1 decimal place. Okay, personally I don't think there's really much of a problem writing 1.728 times 10 to the power of 6. That's absolutely fine, it answers the question, and it is an appropriate degree of accuracy. Okay, so let's move on to question number 13. Two spheres. Spheres means balls. Okay, so just a mathematical name, it just means balls, that's all it is, footballs. Okay, so two footballs have a radii in the ratio of 5:3. So what we mean is that you've got two balls here, one there and one there, okay, and the radius of this ball is 5 and the radius of this ball is 3, okay. Alright, now that's a linear relationship, and this is what's so important with these sorts of things. Because they are balls or spheres, they are what they call mathematically similar, okay. It means they're the same, it's just one is smaller than the other one. Okay, now in a linear relationship you've got a direct linear 5:3 ratio of 5:3. However, if it's a volume relationship, it's actually going to be, the volume relationship is, well, they call it k cubed, but basically it's 5 cubed to 3 cubed, okay, because don't forget that volume is all about 3 dimensions, isn't it? It's, if you had the volume of a cube, it's going to be that times that times that, okay, it's 3 dimensions, okay. So 5 cubed is 125, okay, and 3 cubed is 27, so the ratio of their volumes is going to be that to that. Okay, I hope that's all right for you. Please do have a look at Mathematically Similar. There is a playlist on the channel and it gives you quite a few examples in there, so it might be worthwhile just revising that sort of thing. It would also be helpful with the next one, which is question number 14. Now, question number 14, you just need to really work through a little bit. It's made from two similar trapeziums. So what they mean by that is actually there is a linear relationship between the trapeziums. And they want you to show, the first question, show that the shaded area is equivalent to that. Okay, so what we mean is that if we take the area of the smaller trapezium away from the area of the larger trapezium, we're going to get 294 centimetres squared. The difficulty we've got is we don't actually know this, but we do know that it's similar, okay, but we do need 2 dimensions, and the first dimension we're going to need is the height, okay, and we're also going to need this along here, because you'll remember if you're working out the area of a trapezium, the formula that you need to use is a half A plus B times H. Okay, you need to know that formula for the area of a trapezium. So this particular one, what we're saying is that if we look at height, beg your pardon, if we look at the difference between this 4 and this 18, what we're saying is, what have we multiplied this 4 by to get to 18? No, we're not. This 4 by to get to 10. I do apologise, it's upside down. It's the other way round. So you've got to imagine that this trapezium, this line here links to this, and this one links to this bottom one here. So in other words, what have we multiplied 4 by to get to 10? Well, we've multiplied 4 times 2.5 equals 10, okay? Because 2 times 4 is 8, and a half times 4 is 2, and if you add those two together you're going to get 10. So the scale factor, this 2.5, is the scale factor. Okay, so in other words, the larger trapezium is 2.5 times bigger than the smaller trapezium. Now if we know that, it allows us then to be able to work out the dimensions of the height of the smaller trapezium and this length along here. So let's look at the height first. Now this time doesn't matter which way around this is, but we've got 25 and it's a scale factor of 2.5. So if I divide 25 by 2.5, I get a value of the height of 10, okay? And then similarly with this, now this is a little bit more complex, but if you put it into a calculator you'll be able to work it out, that 18 divided by 2.5 is going to be 7.2. Okay, so now we've actually got the dimensions of both the larger trapezium and the smaller trapezium, and we can simply feed that into the formulas that we need. So what I'm going to write is area of large, okay, and as I mentioned, that's a half A plus B times H, okay, so that's going to be a half. Now A is going to be 18 and B is going to be 10, so that's going to be 28, and H is going to be 25. And if I work all of that out, I've got the area of the large, which is 350 centimetres squared. Okay, similar, I can do that with the area of the small, so area of the small trapezium. Again, a half A plus B times H, okay, and I've got then a half and A plus B, well that's going to be 7.2 plus 4, and the H is going to be 10. And if I work that out, I get 56, okay? So if I want to show that the area of the shaded is going to be the value of the larger one, take away the value of the smaller one, so I can write large minus small, okay, is going to be equal to 350 minus 56, and that equals 294 centimetres squared. Okay, I hope that's okay for you. Please do have a look at that particular question. It's well worthwhile making sure you're okay with that. On the website, I am actually also going to scan all of this working, so you'll be able to see my working and compare it with the video as well. Okay, so let's take that to one side and have a look then at part B of this question. And bearing in mind these are fairly high level questions, so they do take a little bit of time working out, but it tells us that the pattern has one line of symmetry. Well, where is that going to be? If it's one line of symmetry, it means that it's going to be a vertical line that's going to run through this whole pattern, and that's going to be like that. So you can imagine that if I cut this in two, what I would end up with is two very similar or exactly the same pieces, or if I fold it in two, that would match onto that. So it's got one line of symmetry. And then it says work out the size of the angle X. Okay, right, so we've got to be a little bit careful there, but basically we have all the information that we need. We just need to be able to work it through, because actually it's a SOHCAHTOA question, because what I can do is if I draw along here, it allows me to form a right angle triangle. Okay, so if I form that right angle triangle, I can then say, well, actually I can use that in order to answer this particular question. And the reason I can use that is because if I just draw this at the side here, I know that this is the angle X, and the opposite to X, well, I actually know that already, that that's going to be 25 centimetres, okay? I also then can work out this length here, because effectively on the larger trapezium I've got this dimension here, which is 9, and then on the smaller trapezium, or rather this length here, I've got then 5. Okay, so if I've got then 9 take away 5, I can then work out that this length here is 4, okay, because it's made up of 4 along there and then 5 along this piece here. I hope you can see that okay. Have a look at the working when you download this and you'll be able to see that. So I can say then that I've got another dimension on my right angle triangle, which is 4. Now this is actually the adjacent and this is the hypotenuse. So I've got really fairly classic SOHCAHTOA type question, so I can write SOHCAHTOA. Okay, now in this particular case I'm going to be working with the opposite and the adjacent. So if I've got the opposite and the opposite is 25 and the adjacent is 4, what I can do is I can say the tangent of x, which is what I'm looking for, is the opposite divided by the adjacent. Okay, now remember that I'm not really interested in the tan of x. What I'm interested in is the actual angle itself. So what I have to do is on my calculator is I use inverse trig. So on my calculator, if you look above the tan key, usually you can access it using shift or something. If you press shift and then press tan, you should be able to get this inverse trigonometry symbol. And then you would simply put in the value of the opposite, which is 25, and the value of the adjacent, which is 4. And if you plug that into your calculator, you're going to get a value of 80.9097. Okay, and if you want to write that to one decimal place, it would give an answer of 80.9 degrees, and that would be the value of x. Okay, so I hope that's been okay for you. Sorry about the little mistake I had right at the very beginning on part A, but hopefully that's all right and you'll be able to work that through, and this is okay for you as well. Do please also revise SOHCAHTOA. It's a very, very useful skill to have, particularly for higher levels. Okay, so let's then, I think what we'll do is we'll finish at this particular point, okay, and move on in the next video from question 15 onwards. Please do have a look at all of the solutions and compare them with your own solutions. If you've got any problems, please don't hesitate to leave a comment below. I'll always come back to you, and I'll look forward to seeing you inside the next video.